Hello everybody, my name is David. I'll be presenting on the operating system and firewalls components for the server system security section W02 for the spring 2025 semester. First, I'm going to start off with Microsoft Server 2022. This is the newest version of Windows Server, and with it comes many great new features. The first being greater maximum hardware limitations, so it now supports up to 48 terabytes of memory and 2048 logical cores on 64 sockets. It also comes with improved integration within Microsoft Azure environments as more corporations are moving to hybrid environments, multi-cloud and edge environments, so no matter what situation they find themselves in, they can take advantage of these security improvements. Specifically on ARC-enabled servers. Not all servers, but they do have extra benefits there. Some specific security improvements there is that it now supports DNS over HTTPS, which allows for encrypted DNS queries, and that prevents outside sources from peeking in on the websites that users are trying to access. This can potentially, prevent watering hole attacks where a hacker will try to figure out what sites employees visit very often and use those as a weakest link in the chain in order to find a way in. Also, it supports more advanced AES 256 encryption as well as SMP encryption, which can further harden the internal networks. Finally, it also supports HTTPS 1.3 and TLS 1.3. Some hardening recommendations for a Windows Server 2022 environment. Just typical hardening recommendations that kind of apply to environments across the board. It's always a good plan to rename the local admin and change the local admin passwords. Potentially you could remove the local admin and create your own. And then further, you can reduce permissions of built-in groups. Some of these groups like local system, users, and everyone. It's very important to figure out what those are applied to in a default setup, and more specifically for like remote access configuration, you definitely want to remove the everyone group off of that one. It's good to configure an account lockout policy, prevent brute force attacks, where they'll lock out accounts after a certain number of failed attempts. That's also in conjunction with strong passwords and complexity requirements. It's very important to change your default passwords for everything, especially a server, and use strong passwords with complexity requirements that require capitalization, numbers, lowercase, special characters, etc. Finally, this isn't necessarily exactly contributing to like user account security, but BitLocker encryption is very important on servers to prevent someone loading a new image and accessing the data on hard drives. Then in the network configuration side, you're going to want to limit RDP access for remote management, say to a specific IP addresses or within certain subnets within the network. And based on those subnets, you're going to want to make sure the servers are all on secure subnets or virtual LANs. Don't want your servers on guest networks or networks that are less restrictive, especially as you segment your internal network with your firewall. Now we're going to move on to the Ubuntu Server 24, which is the newest release of Ubuntu. This is the long-term support version, that new feature of upping the support cycle to 12 years, which means you'll be able to keep your servers for longer, and they'll have continual security patches and maintenance there that you can perform. It also comes with the new kernel 6.8, which provides performance enhancements for AMD CPUs, as well as KVM virtualization for up to 4096 virtual CPUs. Further, cementing Linux as a more performance-driven system. This is also, in comparison to Windows, open source, and the suggestions and work done by hundreds of different contributors, have resulted in an improved installer, so you can spin up new VMs much quicker, as well as GNOME 46, which is the improved user interface, which gives administrators just more options for managing their servers, even though Linux is primarily a command line driven interface. And then next we have the hardening recommendations for Ubuntu Server. So on two fronts here, we've got software and packages. It's always important to keep your kernel and your software updated. As vulnerabilities are found and patched out, it's not going to improve the security of the machine unless you actually apply the patches. On a similar note, you should only install the necessary packages that you need. Any form of extra software on a system is just another potential vulnerability. So you can use tools like Yum to see installed packages and remove the ones that that serve no purpose. And in the sense of user and admin accounts, some recommendations there. Just like with Windows, it's always important to require strong passwords and password aging policies with complexity requirements and changing the password every so often. One tool you can use, just as a testing tool, would be John the Ripper. You can see how fast that will break your password through a brute force attack. And then similarly with Windows, configuring lockout policies is a great option there. And then most importantly for Linux, you should secure the root account. The root account should be the only account with a UID of 0 and the privileges that come along with it. And a good practice is just to disable the root login, and anytime you need to administer using root privileges, use the sudo command, and that way you never even have to log into the root account. Alright, next we're going to move on to the Windows Firewall. This is the default firewall for the Windows environment. It comes built in to all Windows operating system installations by default, from Home to Pro, and in this case, Server 2022. This is a host-based firewall. It is enabled by default. You can turn it off if you've got another firewall that you're trying to use. And by default, this will block all incoming traffic and allow all outgoing traffic, which is a good place to start. But you should configure rules from there based on the applications that you're going to be running. This supports IPsec, which will allow for encryption on accessing the server, say in an RDP scenario where you're going to try to remotely manage the firewall or the server in general. It'll throw the UAC access controls based on which profile you're trying to log into. And this firewall can be configured on multiple criteria. So you've got the source and destination IP address that you can block or allow specific traffic. You can block it based on the IP protocol, v6, v4, all the above, as well as the source and destination port numbers for, wider control there, and in specific scenarios as well, coming from specific subnets and, external sources. Then some hardening recommendations here. In two spheres, I've got for applications, you can use the event log to track block traffic to apps. By default, say if you've got a server and an application, is trying to send or receive data and the firewall is blocking it, it will notify you, but the event log gives more information to an administrator in order to make sure the rules are properly configured from there. You can also configure rules for the binary or executables of apps in specific. If you're going to open a port for just one app, you don't want to leave that port open all the time. So you can configure a rule to only apply once the app is actually started. So if the app isn't running, the rule blocks the traffic. PowerShell is a Windows tool that is very powerful, both for managing the server and for potential hackers. So therefore, it's important to understand the scope of PowerShell. You can use the scripts for configuring rules, especially if you're trying to spin up multiple Windows servers. You can keep scripts to set a base profile, and then depending on the specific role of this server, you can modify the rules from there. Just speeds up the process of setting up these servers. One thing with PowerShell though is you're going to want to block internet access to it unless you're actively using it for over the internet, which depending on the applications could be pretty rare. You can do this, and you can be sure that hackers aren't going to be able to command and control into the system and then use PowerShell from there to exfiltrate data or escalate permissions. It's also a very smart idea to enable logging on PowerShell, so you can see exactly who's doing what they're doing, and verify that it's all legitimate actions. Finally, we're going to move on to IP tables. This is the firewall that almost always comes pre-installed for every Linux distribution. It's pretty easy to manage and keep updated from there. It operates based on input, forward, and output chains, which is input, which is packets coming in, output, packets going out, and then forward happens when a server receives a packet that's not intended for that server, and it passes it on to another host. So connection states are based on established sessions as well, and that can be used to help figure out what kind of rules need to be applied, especially for something like Secure Shell, which basically should only run if the session is established. And it's an inherent part of IP tables, so it's important to understand. So some hardening recommendations for IP tables. You're going to want to identify which services need network access. So you're going to want to, HTTP, port 80, HTTPS, port 443. Those are some pretty common ones that kind of apply to all servers, but depending on the specific use case of the server and the applications and packages that are going to be running, you're going to want to figure out which ports they need at which times and apply the right chains there. Speaking of applying the right filter chains, you're going to want to know the differences between what we discussed up here, the input, forward, and output chains, and make sure, if an application needs to send and receive data, you apply the input and the output for that specific filter based on the port. One application you can use is rate limiting. This is especially important to prevent denial of service and distributed denial of service attacks, which will measure how many packets are coming in compared to a baseline of how many should really be coming in order to drop some packets as necessary and keep the server running well. You're also going to want to take action on spoofed packets. So once you identify a spoofed packet, a spoofed packet can never really be from a legitimate source. There's probably certain applications there, but they're almost always going to be illicit. So you're going to want to flag or drop those, and you can harden your server that way. That concludes my presentation. I've got a list of references here, and thanks for watching with me.